Dzisiaj mamy małą wycieczkę do Edinburgh Dynamic Earth, takiego centrum, że tak powiem, no powiedzmy naukowego. Także mam nadzieję, że tam parę ciekawych ujęć się przeprowadzi. Tutaj macie na wprost zamek. Między innymi obok jest Queen's Gallery. Oczywiście tym tirem musiał tutaj teraz wjechać dziad jeden, purpurowy. Tutaj macie zamek, do którego przyjeżdża Elka zawsze. Królowa Wielkiej Brytanii. Ona przyjeżdżając zawsze właśnie nocuje w tym zamku, tak? Także oto jest to miejsce. No to jest posiadłość królowej brytyjskiej. Tutaj widzicie, tam za tą bramą, tam jest właśnie główny wjazd z tyłu. Tutaj, moi drodzy, mamy parlament szkocki. Ubogo to wygląda trochę. A może i dobrze, że tak ubogo wygląda. Tutaj macie nawet napisane The Scottish Parliament. W Gaelic też jest napisane. A tutaj już się zaczyna tak zwany Arthur Seat. No jest to wulkan, bo tutaj on czasami dymi. Można tam wejść za parę tygodni, zapewne tam wejdziemy. Tak dla szczegółowości, to już jest wygasły wulkan. Chociaż on paręnaście lat temu on dymił. Także nie wiem, na jakiej zasadzie on jest wygasły, bo on dymił parę lat temu, nie?
Nie wiem, czy to ten, ale chyba tak.
Tak czy inaczej. Jest to wygasły wulkan. On jest praktycznie w środku Edynburga. No to jesteśmy przed tym Earth Science Center całym. Także zobaczymy, co to tam nam ciekawego pokażą.
I have been able to determine the exact age that rocks were formed using their internal clock, the radioactive decay of the elements. We now know that the age of the Earth must be something like 4.54 billion years old.
A my byliśmy w Londynie.
Engine primed, ready to engage time dilator. 5, 4, 3, 2, engage.
Welcome, time travelers. You are about to witness the Big Bang.
Universe age 3 minutes.
The universe has expanded rapidly and is incredibly hot and dense. The first matter is beginning to form.
Universe age 380,000 years.
Hydrogen nuclei are combining with electrons. The first complete atoms are formed, and light is starting to travel freely throughout the universe.
Switching screen to 21 centimeter wavelength. Universe age 200 million years.
The universe continues to expand and form. In the blackness of space, gravity is forcing the hydrogen to collect and concentrate into massive swirling clouds, the first galaxies. Inside these young galaxies, something is happening that will light up the universe.
Universe age 1 billion years.
Pockets of hydrogen gas are collecting together. As their mass increases, they attract more and more hydrogen to form supermassive clouds of hydrogen gas. At a critical tipping point, the pressure caused by gravity forces the hydrogen nuclei at the core to fuse with their neighbors. The energy released creates a chain reaction through the cloud, and a star is born. Stars eventually reach a balance between the force of the nuclear reactions in the core pushing outwards and the force of gravity holding the star together. The largest of these early stars have very short lifespans, burning through their hydrogen in just a few million years. When the hydrogen runs out, gravity collapses the core, and the star explodes in a supernova.
Closing shields. Universe age 3 billion years.
A supernova releases as much energy as your sun will produce in its entire lifetime. All the heavier elements like iron, copper and gold are forged in these supernovae. Over time, the debris from these explosions form clouds called nebulae. In one nebula, a disk of gas and dust has formed around the star you call the sun.
Universe age 9.2 billion years. New timeline, solar system.
In this rotating disk, planets are forming. This is your home planet, Earth, being bombarded by mountain-sized blocks of rock and ice.
Prepare for descent to planet surface. Closing shields. Braking sequence initiated. Landing confirmed. Earth age 2 billion years.
The Earth is now cool enough for you to leave the ship. Enjoy exploring this dynamic planet, time traveler.
Earth's continents, 180 million years ago, unrecognizable to us. Nuclear energy heats the mantle of rock around the Earth's core, and the flow slowly moves the surface crust. The crust is a jigsaw of rock slabs or plates, some carrying continents. Each moves as slowly as our fingernails grow. Coastlines yet exist. But Scotland, even at this time, is moving through different latitudes and climates. Its journey is being recorded in rocks formed on the way. Plates and collision throw up mountain ranges. Where rift valleys open, new oceans may eventually be created. Deep in mid-ocean, where plates pull apart, volcanism builds long lava ridges, venting hot, sulphurous clouds into the sea. On the mid-Atlantic ridge, erupting lava has built an island out of the sea, Iceland. The basalt rock of Staffa was formed by similar effusive volcanism along the junction of the North American and European plates when the Atlantic Ocean began to form. As new crust forms along plate junctions, old crust must make way for it. Where two plates meet, the heaviest may dive under the other and melt into the mantle. You are riding such a plate. It's thinner, but heavier than the approaching continent. The slab of oceanic crust is pulled by its own weight under the continent into the mantle. The Earth quakes. Heat and pressure melt the sea-saturated rock which rises, molten, and explodes into several violently destructive volcanoes. exposes the structure of a glacier. The dark layers hold rock fragments torn from the ground, the rasping teeth of the glacier that fashions the contours of the land. A natural sanding machine, a glacier carves deep valleys, leaving mountain ridges as signposts of its passing. As though hungry for rock, these great tongues of ice lick the valleys into shape, ripping rocks from the side walls and engulfing them in ice. Held at the glacier's edges, this mass of hidden debris is dragged along, grinding at the bedrock, further eroding the valley. Glaciers merge, debris forms a ribbon in the middle of the new glacier. At the tip of the glacier, its leading edge finally melts, leaving heaps of eroded rocks that were carried in the ice. Behind such ridges, meltwater may form a lake. Successive ice ages have left a crumpled blanket of debris across many landscapes. Where ice is melted, the ground is revealed as roughened by the glacier, with deep valleys, rocky scree and mountain lakes. Now running water carves the rock, a further erosive force. Water can move mountains, wearing them down, sifting and sorting rock fragments by size. The fine grains ground down within the glacier melt out of the ice, turning glacial rivers milky as they start their journey to the sea. The Scottish landscape was shaped by glaciers that melted 10,000 years ago. The work of the ice ground down mountains, and rivers washed their fragments into the sands and gravel of the sea, where new rock slowly forms. And in the oceans, life began on Earth.
Wyszliśmy z Science Center. Idziemy znaleźć jakąś restaurację, żeby coś dobrego zjeść. Dużo lepszy obraz jest. Jesteśmy po pysznym obiedzie we włoskiej restauracji. Właśnie tutaj na Starym Mieście w Edynburgu. I jeszcze króciutki spacerek. I zaraz, niedługo, będziemy się zawijali do domu.
Ladies and gentlemen, I'm going to be doing lots of cool stuff today. I'm going to be juggling fire, I'm going to be telling jokes, I'm going to get small children to jump through burning hoops, and I will be telling some lies. There'll be some big porky pies in the show. This bit, however, is the most amazing bit of the whole show. Here we go, dueling the fire props. Ready, 1, 2, 3. Oh my God, look at that there. Dueling is... Okay, it's another lie. Alright, it's another lie. While I do this, I'd like to give you a few tips. Kids, if you want to be a street performer like me, stay in school, okay? I did not get here without the benefits of a university level education. Straight, give me 3 years to juggle, I recommend to anybody. Okay, 2 more little things to do in the start show. We're going to sort out the fire picture. This. Yep. Here. So, very nice. Okay. Okay, right. And now we check the wind. The way we do this, we take the wheel, throw it up in the air, we see where it comes down, we find out if we're going to live or die. Here we go. Show time! Straight up, straight down, everybody lives. Ladies and gentlemen, this is a comedy juggling show. That means if it's not funny, it's juggling, okay? I'm going to do it right now. Join in for the audience. Love this kind of car crash. crash arrangement I've got going on at the moment. I'm going to make what's called a line of danger. Now the idea of a line of danger is that this side of the line is very dangerous, this side very safe, very insured, yeah? Uninsured, insured. Uninsured, insured. It's funny how that works. Now, the reason why this is called a line of danger, and not perhaps a line of safety, because this line is going for 14 years, ever since I was 7 years old. Thanks for laughing, thank you very much. Everybody else, no more math jokes, okay, I promise. No more math jokes. We are fast approaching the limit. Now, in all that time doing fire, there is one thing that's cooler than everything else. I want to start by showing you that thing. So here we go. My favourite thing to do with fire is this. Yeah, don't clap, you'll scare the Americans. Don't worry, sir, it's just the stage you're going through. Thank you very much. Over here, I'm trying to juggle fire, and if people come through the middle, it's actually quite dangerous. And it means that people can't get behind them. Okay, now I know the people at the campus are thinking, you're thinking, why didn't you tell me that was going to happen, yeah? So what I'm going to do, I'm going to go 1, 2, 3, make the fireball again, you can do a photo, also makes a good slow. Ladies and gentlemen, do you want to see something dangerous?